Hello, good morning students, and welcome back to another video for the class 10th of the exercise of the magnetic effects of electric current. And once again we have objective type questions as well as theoretical based questions, so pay attention please, no numericals. At the time of short circuiting, the current in the circuit. So what happens to the current? What actually is short circuiting? So if you remember when I taught you in the previous chapter, that is electricity, as well as this chapter, that short circuiting is a phenomena in which the current increases suddenly in the circuit. Okay, so the options are: reduces, no, it does not reduce. B is it does not change, so that does not count. Third one is increases heavily, yes, but and the last one we just check it if there is nothing different. Vary continuously. Vary means change. Okay, changes continuously, either it increases or decreases, whatever. But the third option is the correct option, that is it increases heavily. So that is what short circuiting is, that when the live wire and the neutral wire comes in contact, the current in the circuit increases suddenly. Okay, increases too much, and that is why it can cause fire effects as well. Okay, moving on, now we have state whether the following statements are true or false. So the first one is: an electric motor converts mechanical energy into electrical energy. Electrical motor does not convert mechanical energy into electrical energy. No, when we provide the current, so it is converting electrical energy into motion, that is mechanical energy. So the first statement is false. That is false. That is the work of electric generator. When you apply the motion on the generator, it converts it into electrical energy. So this is actually the opposite statement. The statement is correct, but for the electric generator and not the motor. So this one is false. So this statement is false. Okay, A is wrong. Second one, an electric generator works on the principle of electromagnetic induction. Yes, we know that. Michael Faraday was the first one to give the electromagnetic induction, and we know that when we provide the motion, that is mechanical energy, it is converted into electrical energy. So the second statement is true. Okay. Third one, the field at the center of the circular coil carrying current will be a straight line. Okay, so we know that, we have seen the coil. Okay, we have seen how the coil works. Suppose this is an electromagnet, okay, right? Then outside it is circular loop, but inside it is a straight line. So once again this statement is also true. Okay. Fourth one, a wire with a green insulation is a live wire. This is false. In the household, you can say domestic circuits or household circuits, you will see that the live wire is actually the red colored wire which has current. The black wire is the neutral wire or the negative wire, and the third one, that is the green wire, it provides the earthing or the earth wire for us to not get the shocks. Okay, so the fourth one is also wrong, that is false. So green wire does not have live wire, it has earthing wire. Okay, now the next question, it is also quite simple. List 3 methods to produce electric current. Okay, so first of all, in order to produce the not the electric current, sorry, in order to produce magnetic field, I have written the question to be wrong. List 3 methods of producing magnetic fields, not electric current, magnetic fields. My mistake, students. Okay, so list 3 methods to produce magnetic field. So first one is when we use a straight conductor and we pass current through it, then magnetic field is generated around it in a circular form. We know that if it is a straight conductor, it is in a circular form. That is the first topic of the chapter that we studied. Okay, the second one is through a circular loop. When you are using a circular loop, the current passing through it will create magnetic field just like this. And the third one is using a coil which behaves exactly like a bar magnet. Okay, so three simple methods for producing magnetic field. First one is circular magnetic fields through a straight conductor. Second one is circular loop. The third one is through a circular coil. Quite simple, all the 3 topics that we studied in the chapter. Okay, magnetic effects. The last one for today is: how does solenoid behave like a magnet? Can you determine the poles of a current carrying solenoid using bar magnet? Okay. What is the solenoid? First of all, to begin, it is an electromagnet that we studied. Okay, and how does it behave like a magnet? So suppose this is the solenoid that you are using, and when you pass current through it, it behaves like a magnet. So the answer for the first question is the solenoid behaves like a magnet when you pass current through it. Quite simple. The solenoid behaves like a magnet when you pass current through it, and such a magnet is called electromagnet. Solenoid is a type of electromagnet. Okay, I repeat once again. Solenoid behaves like a magnet when you pass current through it. And such a magnet is called electromagnet. I hope it is clear to you, students. And the next part is, how do you determine the pole using a bar magnet? Simple. Suppose this is your solenoid, okay, and you bring a bar magnet closer to it. Suppose, let's say this is the south pole and this is the north pole of our bar magnet. When you bring it closer to this electromagnet, suppose this part gets attracted towards this end. That means if this is south, then this is a north pole. It behaves on the general properties of a magnet, that like poles repel, and unlike poles attract. So you can determine the polarity, whether this is the north pole or south pole of solenoid, using the simple property of magnets, that is like poles repel and unlike poles attract. So you can find out the polarity of the solenoid using this simple principle, or the property of a magnet, that is like poles repel and unlike poles attract. So suppose you have a bar magnet and you bring this south pole of the bar magnet towards the solenoid and it gets attracted. That means we have north pole over here and the south pole is on the other end. Suppose you bring the south pole and this gets repelled. So it simply suggests that the solenoid is having south pole and this is the north pole. Once again, very simple. Simply, if you have the understanding of the whole chapter, then you can simply answer the questions of the exercise. Very, very simple. Even if you go through the chapter once again by simply reading it, you will find all the answers to it. Okay. That's all for today, students. We did 4 questions today and hope you have a good time. Have a nice day.